Hello my dear students, we will today speak about the standard hydrogen electrode. It is very difficult, nearly impossible, to measure the potential difference between the electrode and the solution which this electrode is dipped in. But the measurement between two electrodes of the galvanic cell can be easily measured by using what is known as standard hydrogen electrode. This standard hydrogen electrode its oxidation potential as well as the its reduction potential equals 0 in standard condition. So the reduction potential as well as the standard oxidation potential of the standard hydrogen electrode in normal conditions equals 0. We use this standard hydrogen electrode to measure the standard electrodes of other elements. Okay, so what is the standard hydrogen electrode? The standard hydrogen electrode is symbolized by SHE, standard hydrogen electrode. It has a certain composition and a certain also condition. First of this component is a sheet of platinum. Its surface is 1 centimeter square covered by a layer of a spongy divided black platinum. This is a platinum sheet covered with a spongy divided black platinum to absorb hydrogen, dipped in a solution of hydrogen ions. Its concentration is 1 molar. The hydrogen ion in this acid, its concentration is 1 molar. Flow in this sheet hydrogen gas with a partial pressure 1 atmospheric pressure. In these conditions, hydrogen electrode is considered a standard hydrogen electrode, not ordinary hydrogen electrode. A standard where its concentration of the solution 1 molar and at 25 degrees Celsius as a temperature, okay, and a platinum sheet with a surface area equals 1 centimeter squared covered with a divided very finely divided black platinum to absorb hydrogen. So in this condition, this electrode is called a standard hydrogen electrode. So standard hydrogen electrode is an electrode with a very specified conditions and composition. These conditions are the solution of its electrolyte is 1 molar and at temperature equals 25 degrees Celsius, and a flow of hydrogen gas upon this sheet in a condition or in a partial pressure equals 1 atmospheric pressure. So this is a diagram of the standard hydrogen electrode. Another shape or another figure represents the actual hydrogen electrode. Hydrogen gas flow over a platinum sheet, which is here, with a partial pressure 1 atmospheric pressure, okay, and dipped in a solution with hydrogen ion concentration equals 1 molar. This platinum sheet, its surface area equals 1 centimeter square and covered with a finely divided platinum spongy platinum. So what happens here? This diagram shows that the standard hydrogen electrode acts as cathode. So there is a reduction of hydrogen ions in the solution, and by 2 electrons it transformed into hydrogen gas, hydrogen atoms in the gaseous form. So how can we express the standard hydrogen electrode? To express the standard hydrogen electrode half cell, the standard hydrogen electrode may act as anode or may act as cathode. So if it acts as anode, so hydrogen gas will be oxidized into 2 hydrogen ions in the solution. But hydrogen gas flow on a platinum sheet. So hydrogen gas on a platinum sheet with a specific condition 1 atmospheric pressure as a partial pressure of this hydrogen gas transformed into 2 hydrogen ions with a concentration of 1 molar. So there is oxidation from hydrogen gas into hydrogen ions. If this standard hydrogen electrode act as cathode, then 2 hydrogen ions will be reduced to hydrogen gas, 2 hydrogen atoms in the gaseous form. So 2 hydrogen ions with 1 molar as a concentration of the electrolytic solution transformed into hydrogen gas on a platinum with a partial pressure of 1 atmospheric pressure. So what is the importance? What is the importance of the standard hydrogen electrode SHE? It is used to measure the unknown potentials of other elements, electrodes, by knowing its potential. So the standard hydrogen electrode potential always equals 0, whether it is an oxidation or reduction. Reduction potential of the standard hydrogen electrode and oxidation potential of the standard hydrogen electrode, both of them equal 0 in a standard condition. If it is not a standard condition, it is not equal 0. And this is an important point to know. In a standard condition, hydrogen electrode, in standard conditions, hydrogen electrode has 0 value, whether it is reduction potential of the standard hydrogen electrode or an oxidation potential of the same electrode. So the hydrogen electrode potential changes from 0 when? Look at this. This is a very important thing to be asked in the exam. Hydrogen electrode potential changes from 0 when? First condition, the temperature changes from 25 degrees Celsius. The second, the concentration of hydrogen ion in the electrolytic solution, it changes from 1 molar concentration. Or the partial pressure of hydrogen gas, it changes from 1 atmosphere, or both of them means the concentration of hydrogen ion in the solution, it changes from 1 molar, or the partial pressure of hydrogen gas, it changes from 1 atmosphere. If the conditions remain at standard, in a standard condition, the standard condition remains. So in these conditions, the oxidation potential of hydrogen electrode as well as the reduction potential equals 0. But if we change the temperature from 25 degrees Celsius, or it changes the concentration of hydrogen ion in the electrolytic solution, in the standard hydrogen electrode electrolytic solution from 1 molar, or changing the partial pressure of hydrogen which flows over the platinum sheet from 1 atmosphere, in this case the hydrogen electrode potential changes from 0. At this point we will finish and we will start another topic in the next video. Stay with us, we explain everything. Thank you.